Example 2.7. Determine the current through the 3 ohm resistor. Now, because this is a dependent source circuit, I'm going to go through the same process that we've been going through. So let's outline that out. Step 1. I'm going to treat the current controlled current source. In this case, it's 3ix as a regular current source. So looking at this circuit, all elements are in parallel, so I can put them together. So if I come in here and I paste the circuit, and here it is. So you can see that there's only going to be 2 nodes. So let's draw this out. Here's one node, and then here's a second node. So we know for a fact that because there's only 2 colors, they're all in parallel. That being the case, we know that this guy has to be ground. So the one thing that I can't do is that in this guy here, I cannot include in reduction here, because then I lose all that information on IX. So here we go. So now what I'm going to do here is that I'm going to combine all 3 sources. All 3 current sources. So when I do that, you can see that I'm going to have a parallel source current. And so I'm going to assume that it follows the direction of 3ix. So when I look at that, you could see that I'm going to call that my positive direction, this my negative direction. So then that means I'm going to have 3ix plus 4 minus 8. So now I have a source that's 3ix minus 4. So if I redraw the circuit, I'm then going to have 1 source plus 2 resistors. It now looks like this now. So I have a current source that's dependent, and it's 3ix minus 4. Then I have 2 resistors. So this is going to be my 3 ohm. And we see here is that this is the current going down, which is what we're actually trying to solve for. And then I have my dependent, my controlling element, which is the 2 ohm. And this guy has this current, which is Ix right there. So because this is a parallel circuit, I'm going to apply current divider rule. So applying current divider rule, we get that I3 is then going to be the opposite resistance. So then I'm going to get the opposite divided by the sum. So I'm going to get 3 plus 2 times 2 times the current source, which will then give me 3ix minus 4. So if I clean this up a little bit, look what I'm going to do. So if I clean this up, I'm going to get 6. I'm going to factor out a 5 actually. And then I'm going to get 6ix minus 8. And that's what's going to equal to I3 ohm. Now, if I just clean this up a little bit, I'm going to take the 5 to the other side. So this tells me here that I'm going to get a circuit that looks like this. I'm going to get 6ix minus 5i3. And that is going to equal 8. So CDR immediately tells me that I have the unknown of Ix and the unknown of I3. So I have two unknowns. Ix and I3 ohm, and I have one equation. So that tells me here that I'm going to have to get a second equation, right? So immediately this tells me that this is unsolvable unless we find a second equation. And so here we go. That leads me to step 2, which is our dependent condition. What we call the DC. So now that I have that, I could now go in and look at what I'm looking at. So I'm going to go get that circuit. Okay. Here's my circuit right here. Right. It's not the original one anymore. It's this guy. So if I look at this, I have this right here. So what you're seeing here is that now what I do here is that I'm going to come in here and I'm going to do this. I'm going to come right here and I'm going to focus on the controlling element. And that implies here I have to relate Ix and I3 other than CDR. So if I look at this top node, you could see here that I have 3 currents here. So now what I'm going to do is I'm going to apply KCL to red node. So that means that the current coming in has to be the current coming out. And in this case, you could see here that the current coming in has to be what? It has to be 3Ix minus 4. What's coming out is I3 ohm plus Ix. So if I clean this up a little bit, I'm going to bring that, I'm going to bring everything to the left side. Then what this tells me here is that if I do a little bit of reduction here, you're going to see that this guy's going to be 2Ix minus I3 ohm, and that's going to be equal to 4. So now I have a second equation, which I'll label 2. And I don't think I wrote a 1 here. So now I have 2 equations, 1 and 2. So now I can solve my system. So now I'm going to solve my system for I3 ohm. So if I look at my first equation, it's going to be, I think I wrote 6Ix minus 5I3, and that's going to equal to 8. Then if I look at my second equation, you could see here that this is going to be 2Ix minus I3 ohm, and that's going to equal to 4. So in order to cancel out the Ix, I'm going to come in here, I'm going to take the second equation, and I'm going to multiply this by -3. So then after I do that, I'm gonna just add these equations. So the first one, of course, is going to give me 0. And then I'm going to get 5 plus 3, which should then give me plus 2i3 ohm. And then this guy's going to give me minus 12 plus 8. So then this guy's going to give me 4. No, it's going to give me minus 4. Nope, this is a minus sign. I have an error. And this is going to give me minus 4. So then that tells me here that I3 ohm is going to be positive 2 amps.